I'm the director of the garden here. I've been on staff for the last 23 or so years. I've been the director for the past 16 years. And, you know, having the Maker Faire here at Fairchild just feels right for a lot of reasons. But I think it goes back to sort of my approach to botany and the natural world, as well as this sort of collection of interesting people that we have working here, because I see things in a similar way. And it's not necessarily the way the vibe that you would get in other botanical gardens. And I think, after talking to other leaders of botanic gardens about what we do here and what they do, and a lot of our programs are very similar across all the botanic gardens. We're conserving plants. We're teaching younger people about botany. We're trying to encourage people into the field. But I think the difference is that we have a very techno-optimist view here. That's just what I came away with growing up as a nerd that liked to play with computers and hear radio stuff and that. And so getting up to this point where, even in graduate school, I was in graduate school in the 1990s at a time when DNA technology was first being applied to understanding how plants had evolved. So I was able to do is like this fusion of going into the jungle and just very traditional, put on the pit helmet and whack away with the machete and go find a specimen of a plant. But then a week later, you look at your lab and figure out what the secrets are about plant. And so this very old-fashioned kind of field stuff and this new technology just was the most exciting thing. So I've always sort of wanted to be there. And I think when I talk to leaders about botanic gardens, and they have fantastic programs, but a lot of it is, well, the problem with kids today is that they're just on their devices, and we need to get them away from those devices and get them into the garden so they can forest bathe or be in nature or whatever that is. And we don't really have that view necessarily here, that we're not going to pull the kids necessarily away from their devices, but we're going to find a way to make the devices part of the experience. And so that opens up a whole world of possibilities. So I'm going to talk today about the program, a few of the programs we do at Fairchild. Tom has already just mentioned a couple of them to talk about, so there's a whole depth of different things that we do. But we'll start with the Grow in the Earth projects, which is partnership with NASA, where we're trying to support their work on the International Space Station and beyond. We'll talk about the makerspace a little bit, because it is the world physical garden of the world. I used to say the first, and we're sort of waiting for others to someone wanting to have it yet, so we're just going to say only for now. And we'll talk about some of the things that we're doing to try to remake Maya. So take the tech things that we're doing here and try to be a small thing, look back to the future. So, real quick here. Okay, so we're a tropical botanical garden. So we like to tell stories about the tropics. One of our favorite stories to tell about the tropics, and this is Amy Padoff, our director of education. She tells the story very well. It's always part of our DNA here, is the story of Polynesia. The story of Polynesia, as a botanist, I go to any island in the giant Polynesian triangle, from Hawaii to Rapa Nui to New Zealand. Any of those thousands of islands, you find the same 35, 40 species of plants that have no good reason to be there, because there are things that have popped up on these volcanic islands. Taro is on all these islands. Taro cannot live in the sea. They cannot float to the islands. It had to be carried. And then the same with bananas and coconuts and a bunch of other things that arrived at these islands. And we can look at what grows on these islands today and piece together how they got there. And this is the anthropology, the field of trying to figure out the ethnobotany, but the use of these plants and how they arrive where they are. But the way it goes is, and this is taro grown in Hawaii, is that there's some technology involved. 4,000 years ago, people left East Asia, sailing out into the Pacific, navigating by the stars, and they had to build boats. They had to figure out how to navigate. They had to figure out how to live during the voyage, and they had to figure out how to survive when they got to go. And these are some interesting technologies that had to come together, but botany is one of those technologies. So we look at those plants on the islands in Polynesia, and we call them canoe plants, because the only way they could have gotten there is by traveling on these sailing canoes thousands of years ago. So somebody had to figure out which plants to bring. If you wash them, if you have nothing and you land here, you need to have starch, we need to have carbohydrates, we need to have vitamins, we need to have a lot of different things. And so early botanists, starting thousands of years ago, had to make some decisions and fuse that together with all the other technologies. So we look at this thing, and this is a very nice story where we can tell our young students about how botany intersects with technology to expand human civilization. And then we're in Florida, where we have this fantastic space economy, and we think about what the canoes are like today, what we're thinking about, how we're starting to assemble the pieces to go further and carry humans forward. And we've got the International Space Station as our theme. And on the International Space Station, there's something called the Columbus Laboratory Module, which has a glowing pink box, which is where there are some very fledgling plant experiments taking place. And that is called Veggie. And it is, actually there are two veggies on the space station. And so this facility was established on the space station in 2014. Amy and I saw this and thought, well, that's something that could fit into a classroom. And that's something that when you get it into the space station, it is the culmination of tons of research on Earth that has to take place in order to get there. And so we started to think about how we could build an education program that would be tech, that would be botany, that would fuse these things together and actually support that next week of human civilization while we're already teaching kids about camellias and that kind of botany. So we put this together as a program, and at one point we had, and Mario, Tom remember this, and Amy definitely remembers this, where we had to put the technology together to have a live demo with the internet of the space station. Well, I'll let the student explain.
Our school is studying food plants to support research on ISS. How do scientists on the ground help you do science on the ISS?
Yeah, the food research is really important for us, and our experiments are actually designed by scientists on the ground, and they actually help us execute them. We're up here doing the work for them. And scientists include professional scientists, universities, students, and also students in middle and high school.
That's a pretty good synopsis of the collaboration that we've worked out with NASA. We've got now about 400 classrooms that are linked to technology. And there's Dr. Shannon Walker on the space station setting up an experiment. And this is a student in one of our local schools in Hialeah setting up essentially the same experiment. We don't do these things simultaneously. The students do it first. The students test we go through seed catalogs, we go to markets in tropical countries and try to find vegetable varieties that are not on the radar of NASA. And then we'll blast those out to the schools, let the students grow them. Some of them really do not do well. Some of them do very well, and some of them do well, but they taste terrible, like you're having the students. We don't pursue those any further. And the most important thing across all of this uncontrolled experiment, this experiment where all the conditions in the classrooms are very, very different. Students are not always the most responsible, or they're just not consistent in the way they take care of these plants. But what we find is that some of the plants that we test perform consistently, even in this universe of inconsistency. And that is very exciting to NASA. If they see something like, and this is a radar chart where we can look at how consistent the performance is, but this early wonder tall top beet just happens to be one that's consistent in height, biomass, and health of the plant. And so that's a great candidate, because whatever the astronauts throw at it, if they have to do a spacewalk and they can't water the plants in time, those plants are going to be okay. So we're getting tons of data every year from all the schools, and it's very valuable to NASA. One of the first plants to go up was the extra dwarf Bach variety that came out of this program. We've had now 8 different varieties that have come out of the program, Campaduro to the space station. This is on our mission patch, so I have some of those stickers to hand out, but also in the innovation studio you can get those. But around this project that we started really formally in classrooms in 2015, there are a lot of maker-like activities. There's a kit that we send out. Students have to put it together. and they have to run an experiment, and then they get to create their own experiment, which sometimes involves making and modifying the environment. But then we got this flood of ideas for these students. It would really be better if the lights were in a different way, or it would really be better if, and we realized we needed some way to channel all those ideas. And that's when we started talking with Mario, when we started talking with Tom, and Amy had worked in a museum where she had established a makerspace. So we had a lunch together, and we said, "You'd like to start a makerspace?" And Mario said, "Don't do it. Too much trouble. It's really hard to take care of all this equipment." But then we didn't take no for an answer. Nobody took no for an answer. We just went forward with it. And Mario's been the biggest proponent of all this stuff. So what does that mean when we talk about having a makerspace here? You can see this over, it's in our rainforest. It's actually really exciting to have this rainforest part where he's stepping and you're going into the future to see a whole different thing than you would expect to see in the animal garden. And part of it is connected pretty well to our Growing on Earth project. We have a farm bot, which is a robotic thing based on the idea of a CNC, but it's watering and taking care of it. It's scored up. Doesn't work directly, but it works enough that our students enjoy playing with it. And we had a series of grants that allowed us to work with Moonlighter and have a whole series of events and classes and workshops and summer camps and get a lot of kids in our community here interested in maybe to build up some basic skills. We have those, so it's been very popular and very active. And so, we do lots of different things. Print building blocks that allowed us to think about arranging plants in different three-dimensional ways. And then kits for circuit design related to growing plants. And so it's sort of makerspace activities, but all with the idea that there's a goal of growing plants. And it's the goal of growing plants in space, but then it's also the goal of growing plants on Earth and living food systems in this whole bigger plant. And then we had a series of challenges, and we're talking about starting this up again because it was so exciting and fun. But it was a nationwide challenge. We headquartered it here, but we had, the first year we had 120 teams, and it became more complex each year, so the number of teams would have dwindled. I think the last year we had 50 teams or something like that. But we had so many great ideas coming through, and these are open sourced ideas that all exist now. And we took the main questions that NASA has about how they can grow plants more efficiently in space, and we made those the core of these mega challenges. So the first thing is, how do you take your limited space on the spacecraft and use that most efficiently to grow food? The veggie system is a box, but are there more interesting things that we could do than just a box? And we had a lot of ideas of different shapes and sizes of things. I'm not sure if these are the winners, but we judged them. We had a panel of judges, engineers from NASA that judged all these things. So they do have awards.
Yes.
What was that?
We went to a section with this.
Yes, the cool.
Yeah. Oh no.
Yeah, so the first year was that idea. Yeah, there we are. So the first year was the most efficient use of three-dimensional space. The second year was how can we automate these things, sensors, and automate watering. So that got pretty exciting. But a lot of the teams took their first spatial design, carried that forward to Addy since that was the idea. And then the third year was very ambitious. And it's the idea that maybe we could have robotic planting and harvesting. So not just automation of sensors and environmental controls, but how can we actually have something that can grow food without human intervention? And of course, we planned it to be like the DARPA Urban Challenge, where they could turn it on and walk away and then come back and there would be a harvest. Nobody got to that point quite yet, but they put elements together that are really encouraging, really neat. I think this is the one that killed spin and had a blade. The plants got to the right size and cut the views off. It's really neat. So anyway, this is just a great way to reach out to an acre community and plug into this whole vast creative to community that's out there. And then as part of all that, we had this idea that we have a network of schools that we work with in the local community. So let's get them, we can't necessarily bring them all in to build things, but we can ask them to draw a picture of a garden on the spaceship. And basically that. And then we get 1,000 different images from elementary students of different ideas. And this is a third grader had an idea of making triangular shapes that could be stacked. And so we did some prototyping in the makerspace. But it's fun to think that a third grader doesn't necessarily know about the existing system, so I can approach this in maybe a different way. Then there was the first grader who was very first grader drawing of a spacecraft with its pink blobs and plants growing out of them. But the first grader wrote a description that was that they wanted to have a nutrient-rich gel that was kept hydrated with the tube of water. And although NASA has experimented with nutrient-rich gel, they haven't had a way to keep that hydrated. So we did that with a 3D printer and prototyped it. It was pretty exciting, pretty interesting. And I think, oh yeah, the first grade I went to meeting, like the NASA engineer and discussing redesign. So really a lot of fun to be able to be part of this whole community and make some of these questions. And then every year we have a summer internship where we get kids that are really thinking about next generation things. And we had a group of students that had a lot of plans for automation, but really they spent the whole summer on leaf detection. Just how can you kill weeds as these plants grow? And it was really great because it just simplified all the things that we're thinking about. Oh, that could show. And anyway, they developed this algorithm and then covered the to automate systems. And then things like building designing and building things that can grow plants in different environments. So this idea of space architecture and how can you integrate plants, you brought plants into the design of spacecraft. Students working from that. And so this makerspace, to bring it back to growing beyond Earth, in the end, we're also using this to improve the technology that we're sending out to all those classrooms that are doing the Growing Beyond Earth project. So after years of doing this since 2015, we now have our circuit boards that we've designed that make the system a lot smarter. It really wasn't smart to begin with, but now it is. We have our own sensor package that we deploy. And this whole thing is based on the Raspberry Pi Pico that's on the internet, so we can read data from the schools that have this in the classroom. And, yeah, let's look at what the boss looks like now. And it really does have the same capabilities as the veggie system, but the veggie system does not have the sensor package like us. We can actually read a lot more information. This is going to be relevant when NASA's looking at growing plants on planetary surfaces. We have a durometer in our sensor package, so we can see how many atmospheres of pressure these plants are exposed to. We have schools in high elevation Colorado. We have schools now that joined us in the elevation gradient in Chile. And NASA is thinking about building habitats on Mars where it's very expensive to have the strength to raise the air pressure to warm Earth atmosphere. But if you can do half an atmosphere like you would experience on this Hainan in Chile, how will people perform, but how will plants perform? Can we still produce food at that level? So there are classrooms that are going to be able to help us answer these questions, which is really fun, but only because the technology is fused in this activity. Other thing, I have to shout out to Mario. We're building this mini growth chamber now. Here's the big one. And we're building a smaller one, and Mario is still working on the software. It makes it super easy with Bluetooth to control the programming and reading the sensors. We hope to have that available within the next year, so we can have people ordering that and playing with it at home. So it would just be this whole project. It would be something that a lot of different maintenance things can work with and improve. So all this creativity that we've applied to burn plants in space, and I mentioned at the beginning that we're techno optimists here, and we really think about how technology can carry humans forward and improvements on Earth. And we would always anticipate the the techno-pessimism that's out there. And so we've had situations where we talk about this project, the Growing Beyond Earth project, and some of our visitors in the garden hear that and say, "Oh, well, you've given up on Earth, I guess. You're growing beyond Earth." Oh, no, that's not what we mean. We're developing this technology that's, of course, going to have a lot of different applications. But the big thing that we're working on now that's sort of tying all of our programs together at Fairchild is the idea of improving Miami and making Miami more in line with some of the great examples of urban create architecture, design, development that we see in cities like Singapore that is has transformed in the last 30 years into being the greenest city in the world. For me, we're one of the least green cities to be one of the greenest, or being the greenest city in the world. And the idea in Singapore, the vision was that they were going to become a city within a garden. That the overarching idea of Singapore would be, this is a garden, welcome to Singapore, welcome to our garden, and then all the city stuff would be secondary. And we'd love to be thinking of Miami as a city within a garden. So we arrive in Miami, welcome to the garden, and then all the city stuff happens from inside. And we have our students thinking along those lines. We took these ideas of having students draw a garden on a spaceship, now draw a picture of what you'd like Miami. And we get thousands of these images. The idea is, okay, we can actually put green stuff everywhere in Miami. And now that we're able to take these things and fuse them with AI, we can get some things that start to approach stuff that we can see how it might actually be built. And yeah, as I said, we have thousands of these. So lots of really creative ideas out there. And some of them are like this. Some of them are ideas that are citywide, so you can step back and see what Miami would look like. I always like to present those because that's really inspirational. But then, because a lot of these kids have that maker mentality, they are thinking about how the bags are going to work on the balcony watering system. So, and they'll draw that. That's super valuable because we can put all those together in aggregate to make something of this. So we've got all these different components that we're putting together. And what makes a botanic garden? What makes a garden not a park, not a natural area? What makes a garden special is that a garden is a place where plants are grown with intention. And it's the intentionality that's the exciting part for people like me and people. So we decided that we want this place to be a place that's valuable for science. So we grow plants with that intention. Or we want this to be a place for education. And not more. And we want this place to be plugged into regional ecology. So all these intentions come together, and we use these to design in Fairchild and make our programs here. But this is what we want to do citywide. And some of these things like innovative theme design, some of these things like preservation of endangered species. I'm in the London project. I got to experience. Scientific output, food production, involve technology in some exciting ways. Heat mitigations we're not talking about right now because this is about a year ago. We started to look across Miami with thermal sensors and thermal cameras to see. So you don't have to be a genius to see we've got a heat problem here in Miami. And here at Fairchild we have some solutions to that. If you on the same bay go into our rainforest, have a super biodiverse multi-tiered canopy, and we have a high pressure fog system like reverse osmosis water. But a lot of nature and a lot of tech together to make that thing cool, and if you feel the transition that you walk in. So how do we take this technology and blow it up and do it elsewhere? In Miami, we see examples around the world. The Bosco Verticale, the vertical forest in Yaman, is architecturally famous. You can actually put a biodiverse forest on the side of two towers. But if you look at that with film and camera, wow, it's got the same heat signature of the tree. You create this thing, it gave like a forest. So what if we start developing Casey Marine like that? And so what if we take our sensors that we're working on with growing outdoor and start to have them out there so you can get real-time data from the projects that we're working. And then taking it back to Singapore for some really great examples of architecture that are cool that admire. Here's an article we read about a year ago about Singapore's strategy for cooling and how effective it is catching a mile from everybody else. So yeah, things like that are great together. So that's the future. That's where we're headed. Do want to make a plug for a STEM lab. This is our mobile orchid propagation facility. We learn about the mood and orchid project. We'll go into that during depth here. But happy to take any questions and discuss any of these things. And just, beauty of this place is a techno-optimist garden. Real life possible. Thanks for coming.